Hello, I am Jay Prakash, lecturer from Computer Science and Engineering Department, Government Polytechnic for Women, Bengaluru. So, this is the second session of Unit 1. Okay, so it is the machine instructions and the execution of computer organization. Okay, so let us revise the session 1 details. Okay, the basic structures of computers. So, we have seen the different functional parts of the computers. Okay, which are those? The input unit, the output unit, the memory unit, the ALU, and the control unit. So what are the functions of these units? First one, the input unit. The input unit sends the information to the processor, where the output unit displays the processor result from the processor, and the memory unit stores the data. The ALU performs the arithmetic and the logical operations. The control unit performs the control signals, which will send the signals to the different parts of the computer and performs the actions of the different parts of the computer. So these are the five functional parts of the computers. So it will get interact, and the data will be get processed, and the result will be displayed to the output device. Okay. So now we will start the how the interactions between the processor and the memory will be taken place. Okay, before going to this, we're going to define the definitions of these components. Okay, first, the processor contains the number of registers used for different purpose. Okay, the instruction register. The instruction register holds the instruction that is currently being executed. So whichever the instruction that is need to be currently executed, such instruction is ordered in IR. Okay, the program counter keep track of the execution of program. It contains the memory address of next instruction to be fetched and executed. So the program counter holds the address of the next instruction to be fetched and executed. But initially it will point to the first instruction, but later it will point to the next instruction to be fetched and executed. The general purpose registers, these are the n general purpose registers R0 to Rn-1, which can be used by the programmers during writing the programs. The registers used to facilitate the communication with the memory. The memory address registers, which is called as MAR. It holds the address of the memory location to or from the data to be get transferred. So it restores the address of the memory location by MAR. MDR. So MDR stands for Memory Data Registers. It contains the data to be written into or read out of the memory location. So it holds the data which can be read or out of the memory location by MDR. So let us see how the instruction is get executed. So let us take one example of a program. Okay, a program will be executed as follows. So as we know that the program counter is set to the point to the first instruction of the program. Actually, initially it will set to the first instruction of the program. Later it points to the next instruction to the program. So the content of the program counter are transferred to the MAR, and a read control signals will be issued to the memory. So here the two cycles will take place. One is the read cycle, another one is the write cycle. So in order to execute the data, first we need to fetch the data. So that's why a read control signals will be issued. So here is the PC. PC is nothing but the program counter. Okay, it sets to the first instruction of the program. The PC sets to the first instruction of the program, and then the PC are transferred to the MAR, and a read control signal will be issued to the memory. So MAR stands for Memory Address Register. The addressed word is fetched from the memory is loaded into MDR. So the MAR gives the address, okay, and the data from the memory which will be moved to the MDR. Okay, the content of the MDR is transferred to the IR. So after MDR, the data will be transferred to the IR. So what is the function of IR? The IR holds the execution of the instruction to be executed currently. Okay, the current instruction is executed. Okay, that data will be held in the IR, and then the instruction is decoded and executed. So in order to fetch the operands, so what is operands? The operands are nothing but the variables. Okay, these variables stores the data. So if the operand is not present in the register, so if the operand is present in the register, directly the data will be fetched from the operands. But if the operand is not present in the register, the address of the operand is placed in the MAR. So the address of the operand is placed in the MAR, initiating the read cycle in order to fetch the data. The operand will read into the MDR. So whatever the data that is present in the MAR, okay, we are pointing the address there. Whatever the data is present, the operand will be read into the MDR and placed in the general purpose register. So finally, after processing the data by the control and the ALU, so we need to the processed result will be stored back to the register. So in order to store back to the results, okay, after fetching the operands, the ALU performs the operation and the result will be placed into the GPR. So nothing but general purpose registers. If the result is not stored in the memory, then the address is placed in the MAR. So we are going to store into the MER, which points to the memory address registers, and the results is placed in the MDR, and the write signal, control signal is generated in order to put the result back to the register. Okay, this will store the result in the given memory location, which is get pointed out. So this is how the write signals will be performed, and the result will be put into the output registers. Okay, the registers. So this will process continues for the next instruction. So initially the first instruction will be taken place by the program counter, and then the program counter points to the next instruction. So next again the read cycle will be performed, and the address and the data will be fetched and will put it in the registers and perform, and the action will be performed by the control and the ALU operations. And then again the rate control signals will be performed, and the result will be stored back to the register. So this is how the instructions will be executed one after another, okay, in a program. So the next one is the bus architectures. So the question is, what is bus? A group of lines that serves as connecting path for several devices is called as bus. So it acts as a line which attaches to the many components. Okay, examples here is here the input unit, the output unit, the memory, and the processor. So these are the components that has to be connected. Okay, the individual units must communicate over a bus for exchanging the data. So one unit will be exchanging the data with the bus line. Okay, so only two units can actively communicate. For example, from the input devices, if you want to move the data to the memory, so from the input device we send the signals over the line. So from the line the data will be moved to the memory. Okay, again, so one operation will be completed. So from the memory the data will be moved to the processor. So this will be get interacted. So the memory and the processor will be get interacted, and the processor result will be again put back to the memory. Okay, from the memory, if you want to display the data from the memory, we will give back the data to the output device. So only two units can actively communicate at a given time for a single bus. In the case of single bus, what happens? Only two units can communicate with each other. The bus control lines are used to handle multiple requests for the use of bus. Okay, it has a control lines which can handle multiple requests. For example, the request from input devices, the request from output devices, the request from the processor, or the request from the processor can be taken place. Okay, next. So what is the advantage of the single bus? The single bus is of low cost. So the designing of the single bus is very easy. So that's why it is of low cost, and it is flexible to attach peripheral devices. So we can attach many devices to the single bus. So but the disadvantage is only two components can communicate. So many components cannot communicate simultaneously in the case of single bus architecture. Whereas in the case of multiple buses, it can achieve more concurrency in operations while allowing two or more communication to be carried out at the same time. So in order to execute many instructions, because in a computer we are going to handle many instructions at a time. So we need multiple buses. We can achieve more concurrency in operations by allowing two or more communication to be carried out at the same time. Next, for example, we take an example, okay, how the communication occurs by the different components. The electromechanical devices such as keyboards and printers are relatively slow. So keyboard and the printers are slow compared to the memory and the processor, because the memory is almost beside with the processor. Nearby the processor, the data will be get fetched from the memory by the processor directly. But whereas from the keyboard and the printer, when we enter the data by the keyboard, the data will be moved to the memory. Then it will be fetched to the processor. So obviously the speed will be slower from the keyboard. Okay. Whereas from the data from the processor, the execution speed will be faster. So all the devices must communicate with each other over the bus. So whatever the components that are connected, it has to communicate with the bus. in order to synchronize the timing differences among the device. So to synchronize the data, because each components you have to give the time signals. Okay, the buffer registers are used along with the device to hold the information during the transfer. So whatever the data that is sent from the keyboard, it will be stored into the buffer. So the buffer actually stores the data temporarily. Okay, and then it will be moved to the processor in order to perform the action. For example, to transfer the information processor to the printer, the processor sends the character over the bus to the printer buffer. So whatever the data to be get printed, it will be transferred to the printer buffer first. Once the buffer is loaded, the printer starts printing without any intervention by the processor. So when the buffer is loaded, the data that is present in the buffer, it will move to the printer and the printer starts printing. The bus and the processor are released for other activity until the printer prints the content in the buffer. So whatever the data that is present in the buffer starts printing by the printer. At that time, the bus and the processor will be free. So whatever the other data comes from the other devices, it will pass it from the bus and it will move to the processor. And again, the processor will start the data to get printed to the printer buffer, and the data will be get printed. So this is how the data will be get transferred. So basically, what is the difference between a single bus and a multiple bus? In the case of single bus, only two components can exchange the data, whereas in the case of multiple buses, multiple requests can be occurred, and multiple actions can be taken place at a time. But in the single bus, it is of low cost and the design is easy. But in the case of multiple bus, the design is much complicated compared to the single bus. Okay. So next starts the MCQs on session 2. The collection of wires that connects the several devices is called dash. So what is that? The collection of wires that connects several devices. So obviously, so there are different options given. A is an hardware, B is software, C bus, and D interrupts. So the answer is bus. The bus actually connects the different components and data will get passed. Okay. The second question: what are the uses of interrupts? A, recovery from errors. B, debugging. C, communication between the programs. D, all the above. So interrupts actually perform all these actions. So it will record from the errors, it will debug, it will communicate between the programs. So the answer is all the above. So the third question, the group of n bits is referred as word of information of n is called word length. Okay. The dash are used along with the device to hold the information during the transfers. So which are the things which will hold the data? So it should act as a buffer. The options are A, buffer registers, B, program counter, C, bus, D, input output. So the data has to be get hold. Okay. So the answer will be buffer registers. So the next question, dash is set to a point to the first instruction of the program. The bus control lines are used to handle the multiple requests from the buses. So it is set to the point of the first instruction of the program. That is nothing but the program counter. So the program counter actually it points to the address of the next instruction, but initially it will start with the first instruction. So the answer is program counter. The bus control lines are used to handle multiple requests for users of bus. So the control lines are used to handle the multiple requests for the bus. The seventh question, the functional unit of the computers are the input output, B, control unit, C, memory and ALU, D, all the above. So these are all the functional units. So the answer is all the above. IR stands for dash. So IR stands for instruction registers. PC stands for dash. So PC stands for program counter. GPS stands for general purpose registers. Okay. And next, so these are the assignment questions. First one, explain the basic functional unit of the computer. Okay. Second one, describe the role of MAR, MDR, PC, and IR. Third question, explain in brief the basic operation concept between the processor and memory. Fourth one, explain the significance of single bus structure. Fifth one, explain the role of buffer research. So these are the assignment questions. So thank you. So you can refer by the computer organizations by Carl Hatcher, 5th edition. Okay, students, thank you.